So let's have a look at metals and giant covalent structures. Some nonmetals form giant structures with atoms joined together by covalent bonds. These giant covalent structures have the following properties. So giant covalent structures do not have a specific formula because the structure can be any size. And in theory, they can continue forever. So a diamond may have 50,000 or 1 billion carbon atoms. They've got a very high melting point, so the strong covalent bonds between atoms make them solid at room temperature, and high temperatures and a lot of energy are needed to break the covalent bonds in the structure. And they're one large molecule, so giant covalent structures exist as one large structure, and there's no intermolecular forces between, as it's only one molecule. So diamond is an example of a giant covalent structure, and a small diamond can contain 50,000 carbon atoms, but a large diamond could contain 1 billion carbon atoms. And some features of giant covalent structures: they're one large molecule, there's no specific formula, and they have a very high melting point. Pure metals have giant structures with strong electrostatic forces between positive ions and delocalized electrons. All of the ions are the same size, and these ions are arranged in layers. So pure metals have these properties. They are soft and malleable because the ions are arranged in layers and they can easily slide over each other when force is applied. This means that pure metals are often soft and malleable. They also have high melting and boiling points, so there are strong electrostatic forces between metal ions and delocalized electrons, and this means that metals have a higher melting and boiling point. So the ions in pure metals are all the same size and organized in layers. And the structure of pure metals, you have positive ions and delocalized electrons. Some nonmetals form giant structures with atoms joined together by covalent bonds, and the resulting structure is called a giant covalent structure. And some of the properties of pure metals, just to recap, they've got high boiling points, high melting points. They've got layers of ions, and they are soft and malleable. So which of the following describes pure metals? They are soft and malleable. Now, giant covalent structures, remember, they are one large molecule. They have no specific formula, and they have a high melting point.